Hello, I'm going to go over the Simple Machines PowerPoint. Now, you may notice that it says optional, but this is actually very important if you don't know the terminology because you need to use simple machine terminology when describing your product function. Our main simple machines, the wheel and axle, pulley, lever, incline plane, wedge, and screw. You've probably heard about these a number of times, right? An important concept to understand is work. Work is the transfer of energy from one system to another. You transfer energy from one point to another. Mechanical work is the magnitude of the force in the direction of the displacement through a distance. Okay, so notice that in order for work to be done, you have to have movement in the direction of the work. It can't just stand still. Work shows that a force is being exerted and that force is moving something. Simple machines tend to make work easier. Now, this is a very important point. Simple machines do not mean you do less work. In an ideal world, you would do the exact same amount of work with a simple machine as you would just regularly. You just do it over a longer period of time. An example would be you need to lift a box onto a tabletop. Okay? Whether you pick the box straight up and put it on the tabletop, or you push a box along an inclined plane to get to the tabletop, you have done the same amount of work. All right? It just seems like you are exerting less force to do that work, but you're exerting it over a longer distance. That's in an ideal world. Actually, when you use a machine, you have to do more work the more machines you use because there's friction and heat generated that causes a not 100% efficient power transfer. Okay? Which means that even though it seems easier, you're actually doing more work. So the first type we're going to talk about is a wheel and axle. That is two connected circular objects of different diameters. Doesn't matter if it looks like an actual wheel and axle. Okay, a pretty popular one I like to point out that people don't think about is a doorknob, right? A large circular object attached to a small circular object, steering wheel and axle, an actual wheel and axle, all of these. If it is two connected objects of different diameters that are circular, it is a wheel and axle. A special type of wheel and axle is a gear. That's a wheel that has teeth on it. And those teeth get to push against another one so that you can make more than one thing move. A pulley is a wheel and axle with a rope running over it. Okay? So wheel and axle, but then the rope is used. There's a couple of things. A pulley can change the direction of the force. This is a simple pulley. Or multiple pulleys can reduce the effort force to move an object. Once again, fun fact, notice that if it's a single pulley, one rope right here, all right, you are actually not changing the amount of force, the amount of work, or anything done at all. You're just changing the direction of the force. Now, the reason that the pulley makes it simpler to lift 10 pounds than just picking it up yourself is because of the way that the human body works. It is easier for the human body. You can generate more power pulling something straight down than you can pushing something up. This is called a compound. This compound pulley here is also known as a block and tackle. All right. Each one of these lines reduces the amount of force. A lever is a bar that pivots around a point. Many types of levers. Seesaw is a pretty common one. This is a lever. There's another seesaw. A crowbar uses the principles of levers. All right. Right here, the handle of this nozzle is a lever. A wheelbarrow is a lever. Right? Think about it. The wheel is where it pivots, and the handles are the bars that pivot. There are three components. You have to have a resistance force. That is what you're trying to lift. The effort force that you are lifting, and the fulcrum, which is the pivot point. Right? Three types of levers. Number one is a first class lever. The effort and resistance are in the same direction. All right. Fulcrum is between the two. Think about a seesaw. That's a first-class lever. Another example of a first-class lever, this right here, all right, using an object to lift something up. All right, notice that levers can actually make work easier or harder, okay? Easier or harder. It doesn't have to be the same. Sometimes, well, we'll go through an example with a third class. A second class lever is the resistance forces between the fulcrum and effort. Effort and resistance are in opposite directions. Every time I say second class lever, think a wheelbarrow. You lift the wheelbarrow up here with your weight in the middle of it, in the basket, pivoting on the wheel. All right? Third class lever. The effort force is between the fulcrum and the resistance forces, and effort and resistance forces are on opposite ends. All right. The third class lever is the hardest one for people to kind of understand. Okay. Because it doesn't seem the most obvious. But one good example of a third class lever is tweezers, okay? Or kitchen tongs. So think about this. This end down here is the end of the tweezer or tongs. You squeeze them together in the middle, all right? And you grab something, your resistance at the end. So these can be really useful for taking an amount of force and reducing it down to finer detail. An inclined plane, slanted surface used to raise an object. All right, we've seen many examples of inclined planes. You're probably fairly familiar with this. It's a ramp. Specialized types of inclined planes include the wedge and screw. These are actually inclined planes used for different reasons. A wedge is an inclined plane, a moving inclined plane that can split, cut, tighten, or hold things together. This inclined plane, this wedge, actually changes the direction of the force. Think about this. As a saw comes down, as a knife comes down, as a hatchet comes down, it splits an object apart. Okay? A screw is an inclined plane wrapped around a shaft. Screws are used to fasten things together or to move things. Screws are really useful in transferring a rotational force into a linear force, okay, or a circular movement into vertical, horizontal, that type of movement. Think about this. We're driving in circles on a parking garage ramp, but our ultimate movement is from top to bottom. And those are the type of simple machines. This is the type of language that you'll want to use when completing your functional analysis assignment.